The history of life on Earth is a fascinating tale that traces the evolution of living and extinct organisms from the earliest emergence of life to the present day. Earth itself formed about 4.5 billion years ago, and evidence suggests that life emerged before 3.7 billion years ago. Isn't it incredible to think about how ancient life on our planet is? The earliest clear evidence of life comes from biogenic carbon signatures and stromatolite fossils found in 3.7 billion-year-old rocks in western Greenland. In 2015, potential remains of biotic life were discovered in 4.1 billion-year-old rocks in Western Australia. Could these be the earliest traces of life? Additionally, fossilized microorganisms in hydrothermal vent precipitates from the Nuvvuagittuk belt might date back to 4.28 billion years ago, shortly after the oceans formed around 4.4 billion years ago. Earth itself formed 4.54 billion years ago. Yet, these early fossils might have originated from non-biological processes. What do you think? Could these findings represent life, or are they merely geological artifacts? In the early Archean eon, microbial mats of coexisting bacteria and archaea dominated life. Many major evolutionary steps likely occurred in this environment. Around 3.5 billion years ago, cyanobacteria evolved photosynthesis, leading to an oxygen buildup in the oceans. Once free oxygen saturated all available reductant substances on Earth's surface, it accumulated in the atmosphere, triggering the Great Oxygenation Event around 2.4 billion years ago. The earliest evidence of eukaryotes, which are complex cells with organelles, dates to 1.85 billion years ago. This probably resulted from symbiogenesis between anaerobic archaea and aerobic proteobacteria adapting to oxidative stress. Could the partnership between these ancient microbes have set the stage for all complex life? Eukaryotes may have existed earlier, but their diversification accelerated when endosymbiont mitochondria enabled more efficient aerobic respiration, providing abundant biological energy. Around 1.6 billion years ago, some eukaryotes gained photosynthesis through endosymbiosis with cyanobacteria, leading to the rise of various algae that eventually overtook cyanobacteria as the dominant primary producers. By 1.7 billion years ago, multicellular organisms with differentiated cells performing specialized functions appeared. Initially, organisms reproduced asexually, but sexual reproduction, fusion of male and female gametes to create a zygote, became the primary method for most macroscopic organisms, including almost all eukaryotes. What drove this shift from asexual to sexual reproduction, and how did it change the course of evolution? Microorganisms formed the earliest terrestrial ecosystems at least 2.7 billion years ago, and the evolution of plants from freshwater green algae dates back about 1 billion years. Microorganisms likely paved the way for land plants in the Ordovician period. Land plants were so successful that they may have contributed to the late Devonian extinction event. Early trees like Archaeopteris reduced CO2 levels, causing global cooling and sea level drops. Their roots also increased rock weathering and nutrient runoff, possibly triggering algal bloom anoxic events. Did the success of these early plants inadvertently lead to their downfall? Bilateria, animals with left and right sides that are mirror images, appeared by 555 million years ago. Ediacara biota emerged during the Ediacaran period, while vertebrates and most modern phyla originated around 525 million years ago during the Cambrian explosion. During the Permian period, synapsids, including mammal ancestors, dominated the land. The Permian Triassic extinction event, 252 million years ago, killed most complex species of the time. During the recovery, archosaurs became the dominant land vertebrates, with dinosaurs ruling the Jurassic and Cretaceous periods. After the Cretaceous-Paleogene extinction event 66 million years ago wiped out non-avian dinosaurs, mammals rapidly diversified and increased in size. Do mass extinctions accelerate evolution by providing opportunities for new groups of organisms to thrive? Despite extensive research, only a tiny fraction of species has been identified. One estimate suggests Earth may host 1 trillion species, with identifying every microbial species being a significant challenge. To date, only 1.75 to 1.8 million species have been named and documented in a central database. Currently, living species represent less than 1% of all species that have ever existed on Earth. Imagine the vast number of life forms that have come and gone throughout Earth's history.